Good morning and welcome to today's class. Today's class is a continuation of our previous classes on trigonometry 1. At the previous class, we looked at the basic trigonometric ratio of sine theta, cos theta, and tangent theta, which we said the sine theta is said to be the ratio of the opposite side to the hypotenuse side, while the cos theta is said to be the ratio of the adjacent side to the hypotenuse side, and the tangent theta is said to be the ratio of the opposite side to the adjacent side of a right angle triangle. I did explain to you the right angle triangle, identifying the three sides and angles. We also looked at complementary angles, where we said two angles are said to be complementary if their sum total gives you 80 degrees. And with that, we were able to solve so many examples using the trig ratio, where we established the relationship that cos theta is said to be equal to sine 90 minus theta. That is, the sine of an angle is equal to the cos of its complement. We used that to solve a lot of examples, and I left the class with an assignment where we are asked to do the following: that using the trigonometrical tables, we should find the sine, cosine, and tangent of each of the following. We have about 8 angles which we are asked to find the sine, cos, and tangent of them. In today's class, we shall be solving these questions. So in answering these questions, all you need to do is to have your trigonometric tables handy so that you can be able to look out for each of these angles. To enable us solve this, I have prepared a table of the angles and a column for their sine, cosine, and tangent. So we shall start with the sine table of these angles. In order for us to get the value of sine 0.3 degrees, you are to go to your sine table and check for 0 under 3. Because this is 0.3, it therefore means that the angle is not up to 1. Now let's have a look at the sine table. This is an example of our sine theta table. If you look very well, you see this is sine of angles, where the angle x is in degrees. That means the angle is in degrees. And on the first column here, you have the values of all these angles. So this is angle 0, angle 1, angle 2, angle 3, angle 4. You have it down to angle 44, and for angle 45 down to angle 89 continues on the second half of the page. So this is angle 45, 46 down to angle 89. So if you are asked to find the value of sine 0 using a sine table, it therefore means that you have to find the angle of sine 0.0, and sine 0 under 0 is said to be 0, while sine 90 is said to be 1. And I will give you a better explanation. Why is sine 0 0 and why is sine 90 1? If you go back to this, where we have an angle theta, now this is said to be the opposite side when you draw a perpendicular. This gives us the opposite side of this right angle triangle, and this is said to be the adjacent, while this is said to be the hypotenuse side. Now this is a circle of radius 1 centimeter, and the angle keeps increasing. At the point the radius gets to this point, is turning until it gets to 90. Now at the initial, when it is at the x origin, we have already established that sine is said to be the ratio of the opposite side to the hypotenuse side. Now what is sine 0? Sine 0, it therefore means that the angle at this point is 0. It therefore means that line OP is lying across line OX. When you are asked to find the sine of that angle, which is said to be the ratio of the opposite side to the hypotenuse side, you agree with me that the opposite side, as this angle keeps decreasing, the opposite side gets to 0, because this is the hypotenuse and this is the height, which is the opposite. So the opposite side keeps decreasing until it gets to 0 when the angle is 0. So at this point, we therefore say that the opposite side is 0, while the length of the hypotenuse, which is the radius of the circle, is still said to be 1. And 0 divided by 1 is said to be 0. So that is the reason why sine 0 is said to be 0. What about sine 90? Sine 90 is said to be of this form. At this point, what will you say is the opposite side to this angle. As you keep increasing, this gives you the opposite, and when it gets to 90, you agree with me that the opposite side aligns with the hypotenuse. We have it that the opposite side becomes 1 centimeter and the hypotenuse side is equal to 1 centimeter. So sine 90 is said to be 1 divided by 1, which is equal to 1. The sine of any other acute angle that lies between 90 and 0, its value falls between 0.00 to 1. So that is why if you look at the sine table, the value starts from 0.00 and it ends at 0.999999 something. So this is 1, okay, approximately 1. That is to say, this is the value of 89.9. It therefore means that every other value falls between 0 and 1. Now, with that knowledge, let's understand this sine table. We have about 10 columns before the difference columns. The first column gives you a value of x. We have already told you that x stands for your angles, the whole number part of your angles. Then you have the fractional part, where this is 0.0, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Now we are asked to find the value of sine 0.3. So I'm going to use my sine table to get the value of 0.3, and this is said to be angle 0.3, and angle 0.3 falls here. So this is the value of sine 0.3, and sine 0.3 is said to be 0.0052. 0.0052. B, we should find the value of sine 60.5. So I'm going to look for angle 60 under 5, because this still falls within the range of 90 degrees. So go back to your trig table and look for 60 under 5. So this is angle 60, 60.5. This is 0.01234, 0.12345. So angle 60.5 gives us 0.8704. 0.8704. Next is angle 88. Angle 88 is still an acute angle. It falls between 0 and 89. So we shall get the value of angle 88. And angle 88, using your sine table, is down there. So this is angle 88 under 0. So angle 88 is said to be 0.9994. So this is 0.9994, while angle 45.5 will give us 45.5. 45.5 is up there. So this is 45.5. It gives us 0.7133. 0.7133. Also, angle 26 is still an acute angle. Go back to your sine table. This is angle 26.0, and it's said to be 0.4384. 0.4384. F says we should look for angle 108, and angle 108 is said to be in the second quadrant. So this is angle 108, a sketch of angle 108. And since angle 108 has gone to the second quadrant, remember we are told that in the first quadrant all the trig ratios are positive. In the second quadrant only sine is positive. In the third quadrant tan is positive, and in the fourth quadrant cosine only is positive. So the trig ratio of angle theta of angle 108 is equivalent to angle 180 minus theta. So angle 180 minus theta, if you subtract 108 from 180, it gives you 72. So we have it that the sine of 108 is equivalent to angle 72 because 108 is greater than angle 90. So therefore, we can't get its value because it now spills into the second quadrant. And in the second quadrant, it is said to be equivalent to angle 72. So sine is positive in the second quadrant. So what you would do now is to get the value of angle 72, the positive value of angle 72 in the second quadrant. I will then look for the value of angle 72 and take the positive value, because at this point y, which is the opposite side, is still positive, but the only negative side is the x value, which is the adjacent. So y is still positive, so we shall look for sine 72, which is equivalent to sine 108. Sine 72.0, if you punch your calculator, this is still what you get. So 72 under 0 is said to be 0.9511. 0.9511. We also do same to angle 135. Angle 135 is also said to be in the second quadrant, and sine is said to be positive in the second quadrant. So subtract 135 from 180, that gives you the equivalent, and this is said to be, this is 5, angle 45. So therefore, this is equivalent to sine 45. So you have it that sine 135 is equivalent to sine 45. So sine 45 will be, let's look out for sine 45. So that's 45 under 0. And sine 45 under 0 is said to be 0.7071. 0.7071. Sine 111.5, just like what I said, 111.5 is greater than 90. So we shall look for its equivalent in the second quadrant. That will be 180.0 minus 111.5. This gives us 5, 8. So this is equivalent to angle 68.5. So I shall look for the value of angle 68 under 5. So this is our angle 68 under 5. This is 0, 1, 2, 3, 4, 5. This is 0.9304. 0.9304. These are the values of sine theta. You can as well use your calculator to confirm the values of all this and see if it gives you approximately what we have here. Kindly like our videos as you watch, while we recommend that you subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that seems difficult for you. Also share the link with your friends and families so that they can also benefit from this class. We shall then look at the value for cos theta.